Good morning, dudes. We're gonna talk about introduction to pointers in C. So, what is a pointer? Pointers are variables that store the address of other variables. Normal variables have direct access to data, which is they can only access the value that's assigned to that variable. Now, pointers have indirect access to data, which is they can access the value of other variables. For example, in this memory, which is the RAM memory of our computer, there are tons of addresses to which variables are assigned to. For example, in this integer variable a that is equals to 5 is assigned to some free address of memory, which is 108 in this case, of size 4 bytes because it's a data type integer, which is 4 bytes. So from 108 to 111 is going to be the variable a. Now, when we declare a pointer type integer and we assign the value of the pointer, the address of the value of the variable a is going to be the same process as the variable is going to be assigned to a free address of memory, the same size as the other integer variable, but is the value of the pointer is going to be the address of a, which is 108. So every time we modify a, we're going to modify the value of p. So pointers have to be of the same data type for them to work. We cannot have a pointer of type integer pointing to a variable of type character, for example. Pointers have to be initialized to a valid address or to null, which is pointed to nothing. Thing is, we don't want the pointer to point to a variable that has junk on it. So the uses of pointers in C are a couple. It enables us to access any location in memory by accessing the addresses in the memory, as we saw before. We can manipulate data structures such as lists, stacks, queues, trees. For example, the use of strings in C. In C there are no strings. Instead, we use an array of pointers of type character to simulate a string. We can manage dynamic memory, which is allocate memory, which is you define a size of bytes for a variable. For we can assign more bytes than default to each variable, for example. And we can also free memory, which is we can empty unused addresses of memory. This is to avoid memory leaks, which is when you completely fill your memory of useless addresses, useless data, and make your computer crash. We can also emulate reference passing. Now, pass by reference does not exist in C. We have value passing in C, which is when you have a function that has to get an array, for example. We don't pass the array to the function, we pass the address where the array starts because we want like an array of pointers, we want the first address so we can then start manipulating the array. So that's how we simulate that. So the manner in which we access data in pointers is using ampersand to get the address of the pointer, using a star, an asterisk, for accessing the content of the address where p is pointed at. And we can also access the address where p is pointed at by just simply printing the pointer variable. So in this program we see an example. We have an integer a equals 5 and an integer pointer p. Now p is pointing towards the address of a. So when we print the information we can see that A is equals to 5, the address of A is equals to this number, P is equals to the address of A, because it's pointing at the address of A. Now the address of P is completely different than the address of A, but the content inside the pointer is equals to A, equals to that content. We can also point pointers to other pointers. As we see in this example, we have a pointer C that is pointing towards the string hello. Now we have CP that is pointed towards C, and we have CPP that is pointed towards CP. Now these two are pointed not to normal variables but to other pointers. So that's why this one has 2 stars because it's pointing to another pointer, and that's why this one has 3 stars because it's pointing to a pointer that's pointing to another pointer. So we can see here that C, for example, is pointing towards the first address of the string hello. We can see that CP is pointing towards the content of C, and we can see that CPP is pointing towards the content of CP. Yeah, here you are. Yeah. So this matter of structuring pointers is useful for when you want to simulate like linked lists. In this example, we can see that by manipulating the number of stars that we use, we can see different types of information. For example, C is pointing towards the first address of the string hello, which is H. If we use a 1 star on CP, which is the pointer pointed towards C, we can access the content of C, which is the $sign. But if we use 2 stars on CP, we can access also H, which is the first address of the string hello. This applies the same for CPP. With CPP, we can access the same stuff that we can with CP and C, as we see here. Pointer increment and decrement. This is pretty useful for when you want to access, for example, the characters on a string. We modify the address to which the pointer is pointed at, so we can access different addresses, different characters. For example, we want to print out a string, which is a pointer of characters. We simply modify the address to which it's pointed at, and we can see on the screen how we change the address each time. In this case, is a different character. We can decrement it and increment it as a normal variable integer. Okay, so alloc and free, allocation and free memory. So we were talking before about allocation. In allocation is you can define a certain size for a pointer of n variable. In this case, C string is a pointer of type character. Now, a pointer of type character is normally 1 byte, but here we define that we want 15 bytes for this variable pointer. And so we copy a string to our character, to our pointer of character, and then we print it on screen. So we have that the content inside that pointer is going to be the string which we copied before, and the address is this. Now when we free memory, we erase the content of that address specific. So it's pretty useful because we don't want memory leaks. We don't want to have addresses full of data that we're not using anymore. This is very crucial, for example, in servers, that those are computers that are always on, so they cannot refresh their memory. So we want to always discard the addresses that we are not using anymore, so we can have always memory available. So we can see here that when we free the C string, there's just trash inside the strings, and there's nothing there. It's not the address doesn't have information anymore. So these were some of the major functions of pointer in C. Thank you very much.